everyone, and welcome back to this Arduino tutorial series. We have been looking at the joystick, and last time we wired it to the Arduino and saw what kind of values that we got from it, and we're going to use these values today to control LEDs. If you are totally new to using joysticks with Arduino, I highly recommend you watch the first video in this series. This first one's black, so it's my ground wire, and I'm just going to put it into the ground pin of the Arduino. The next one is my red wire, which is our 5 volt, and that's going to go in here into the 5 volt of the Arduino. The very first green one here is our VRX. And this reads the values along the X plane, and I'm going to put that into a 0. And then finally, we got our Y, and that's going to go into a 1. I'm hoping one of you guys is remembering all these pins, because I sure won't. And finally, the switch. Let's put that into pin number 2. He's kind of like all by his lonesome because the switch is digital. It's either pressed or not pressed. It's not in between. Whereas the X and the Y are analog, meaning they are going to provide values anywhere from 0 to 1023 or 1023. So now let's see what we got going on with these LEDs. And you'll see that conveniently, I have them laid out kind of like a joystick situation right here. So the idea is that thumbing left will turn on the yellow one, up the red one, right the blue one, and then down the green one right here. The anodes are all hooked up to colors. I'm going to just connect it via a resistor, and I want to pick PWM pins because the idea is when I thumb, I want the LED to fade up, and when I'm all the way, it's going to be at maximum brightness and then fade back down to nothingness. So let's see for PWM values. The yellow I'm going to put into 11, the red into 10, and the green into 9. And then finally the blue is going to be by his lonesome because the next PWM pin is going to be number 6. So he's kind of quite out there. Now when you're hooking up via resistors like I am, it's super important that the little legs don't touch each other. So you want to make some space. The anodes are all hooked up to the Arduino, and the cathodes, the negatives, they're all tapping into this ground rail, which is hooked up to nothing. I'm going to just grab this last little hole right here and put it into the ground of the Arduino. So that way we're all hooked up. So let's go to the code. Starting with a completely blank sketch, we are going to write this from scratch, people. No pre-made code for us. So first thing we're going to do is define all of our pins. And I hope somebody took notes because I sure didn't. So let's just go for it. Let's start with our joystick. And let's call it X pin, and that was connected to a 0. And then our pin for the Y coordinate was connected to pin A1, and let's not forget our semicolons, the dreaded semicolons, and curly brackets. Those will get me every time. And then the button pin, that was connected to number 2. He was all out there by his lonesome. And then we are probably going to need a couple variables just to store some information for us, like the X value, similarly the Y value, and then a variable to track our button state. Is the button pushed or is it not pushed? So now that we have kind of our joystick stuff out of the way, let's define some of the LED things. So LED pins. The up LED, and we'll call them like up, down, left, right, because you guys might be using different colors. So for the up LED, I believe that was pin 10. Down LED, I believe, was pin 9. And the left LED had to have been pin 11, which means that the right LED was the one that was kind of on its own. I think it was pin number 6. We'll soon find out. Because we are going to be fading them in and out, we're going to need to store values for fading these. So for each LED, we can call it the up brightness, like the up LED brightness. And I guess we'll need brightnesses for all of them. the down brightness, and then the left brightness. Kind of a long variable name, but I'm going to go for it. Brightness. Maybe we can call it like down bright, left bright. But I'm committed now. And you know what? Let's start these all off at 0. And one more. So when the sketch fires up, everything's going to be off. Let's set up pin modes for all of our pins so the Arduino knows whether to treat the pin as an output or as an input. Let's start with the joystick, and the pin mode of the X pin is going to act as an input because it's going to be inputting information into the Arduino. And same thing for the Y pin of the joystick, that's also going to act as an input. And then the button pin, that's also going to act as an input because it's going to be telling the Arduino, am I pushed or am I not pushed? But with buttons, we have to use resistors, either a pull-up resistor or a pull-down resistor. Luckily, with the Arduino, we can use its internal pull-up resistor, so we don't have to use any more components in our circuit. We took care of the joystick. Let's take care of each of the LEDs. So pin mode for the up LED is going to be an output. All these are going to be outputs. And the right LED. Right off the bat, what do we want to happen? We want the Arduino to read the X value, the Y value, like where is this joystick, and also the button. Has the button been pushed? Let's read the X value or grab that X value. And we do it by analog reading that A0 pin, which is the X pin. And likewise, we are going to grab that Y value as well by analog reading the Y pin. And then we got to collect the button, so the button state. And we're going to do that a little bit differently. We're going to do it by digital reading the button pin because the button is either pressed or not pressed. There's no in between. Whereas the X and the Y, there's in betweenness to that. So now we have all of the information that we need. Where is the joystick along the X axis, the Y axis, and is that button pushed? Now let's do something with this information. We need to translate these values into LED brightnesses. In order to map all of our values, we are going to use the map function. And if you've never used it, basically you have a target that you want. So this can be the brightness of our LEDs. And we're going to use the map function, and it takes a couple parameters, like the source of the mapping. What is it that you are going to take and then map to something else? So for us, it's going to be the X value or the Y value. And so the source low, like what is its low end? And then what is the source's high end? And then after that, you want to put what the target is, what is their low end? So target low, and then the target high. Basically, all this means is that it will take a source, like the joystick position along the Y-axis, map the source's low to the target's low, and then the source's high to the target's high. So let's see if we can make this all work out. The first one that we want to map, let's just do the up LED. Stay in order. So the up brightness. And we are going to use our map function. So how are we going to get the up brightness? And as we know, brightness of LEDs go from PWM 0 to 255. 0 being all the way dim, and then 255 being all the way bright. So let's start with the Y value, because in order to light that top LED, we're going to have to thumb up on our joystick. So that's a Y value right there. And what is its low? The Y goes from 0 to 1023 or 1023. And so middle of that is like 511 or 512. But what I found with my joystick, my Y value, the middle is more like 489. And so if you have not run the code to find out what the idle is for your joystick, definitely do that first before you do something like this, because your results can get a little bit wonky and it's going to save you a lot of troubleshooting. So link to the first episode in this series is below, and then jump back here, join us where we are. The Y value, as it's in the middle, is 489. If I thumb up, the values go down all the way up to 0. What do I want to map that as an LED brightness? Well, when it's in the middle, 489, I want that brightness to be 0, off. And when it's at 0, thumbed all the way up, I want it to be full blast bright, like blind me. Now, similarly, our down brightness, that LED at the bottom, we're also going to map it using the Y value. So again, while it's idle, it's going to have a value of 489. Now, as I thumb down, the numbers are going to increase until I max out at 1023. So I'm going to put that value in there, 1023. When that joystick is at idle at 489, I want that light to be off. And as the joystick goes down all the way to 1023, then I want it at maximum brightness. We have the left brightness, and now we're moving left to right. So instead, we are going to be mapping the X value. And for me, my middle was right around 511. I want the LED to be off. As I thumb to the left, the numbers are going to get lower for that X axis all the way till it hits 0. So in LED terms, when it's 511 in the middle, I want the LED to be off. All the way left, I want that LED to be full on bright. So now we have one more to go, which is the right LED. And again, we are mapping the X value, and starting at the middle, it is at 511. And as I thumb to the right, that value is going to increase and max out at 1023. Likewise, I want my LED to start at 0 when the X value reads 511, and I want it to go all the way to max brightness at 255 when that thumb is all the way to the right at 1023. Now we are going to end up with a whole bunch of if statements. If the Y value is less than or equal to 489, this means I'm thumbing up because the values are decreasing. That means I want that top LED to start getting bright. We're going to analog write the up LED by the up brightness. So basically, the code is reading the joystick. It's grabbing the X, the Y, the button state, and then it's putting it through this mapping process. So if I'm thumbing up, it's going to grab the Y value that it just read, and it's going to see where I am and assign it a number from 0 to 255, which gets put in this up brightness. And then it writes that corresponding LED, which is the up LED, by its up brightness. So then if the Y value, now we're going to thumb down, is greater or equal to 489, what do we want to happen? Well, we want to analog write that down LED by the down brightness. And now let's work along the X axis. So if the X value now thumbing left, that means the numbers get smaller, is less than or equal to 511, we're going to analog write the left LED by the left brightness. And we have one more of this business. If the X value, let's thumb to the right. If the X value is greater than or equal to 511, light up that right LED. So we're going to analog write the right LED by the right brightness. We're crushing this. Oh, I just jinxed it. Oh, I smell an error coming up. Let's put the button into use. So say if I push the button, all the lights just light up. And then when I let go, they go off. If the button state is equal to low, and low means the button has been pressed because we are using the internal pull-up of the Arduino. That means when the button is not pressed, it's going to emit a high signal or a 1. And when it's pressed, it's going to emit low or a 0. So it knows it has been pressed. We are going to light up all of the LEDs. So digital write the up LED high. And then finally, the right LED. It's going to go high. All right, everybody, you know the rule. Throw shade at it, give it side eye, really put the fear into this code so it doesn't error out on us. Look at this spelling error right here. Input pull up. Yeah, let's get rid of one of those L's. The moment of truth. Let us thumb up and see if that red LED comes on. Oh, nice. And it goes off. What's this blinking situation right here? This circuit's giving me a little bit of sass. That is not appreciated. Let's see the green. All right, and it turns off. Blue. Yellow. All right, it seems to work fine. It's a little glitchy. We do have a bit of a gremlin. Let's see what happens when I push the button. All of them come on like they're supposed to, and they all turn off. All right, so the button is working pretty well, but we are getting a little weirdness going on where I'm not even touching it, and it's freaking out. So many of you are going to run into this problem with this joystick. So let me show you what adjustment to the code that you can make. Take another look at your circuit, make sure everything is wired correctly. And that's pretty much eliminating the obvious before you like pull your hair out doing all of the code troubleshooting. So let us commence to pulling our hair out. In the first video of this series, we ran code to determine what the idle position of our joystick is. And what a lot of you guys are going to find, it's not just one number. It's going to fluctuate between 2 to 3 numbers, both in the X and in the Y positions. So what's happening with this code is that even though we've specified 489 to 0 and 511 to 0, which is mostly where my joystick is, there are times where in the X position, my joystick will read 509 or maybe even 512. Well, that's being mapped to the brightness. So it's just going to flicker on real dimly. So unless you have a joystick where the numbers are solid, you just get the one number for both X and Y, you're going to have a bit of gremlinage. One of the things we could do is create a dead spot right in the center where nothing lights up. So in order to do that, take the number that you see the most. In my case, for the Y value, it is 489. And we are going to add some numbers to the left and to the right of that, meaning lower and higher. In this first statement here, it's assuming that we are thumbing up. When we thumb up, the numbers get lower. So let's go lower than 489. I'm going to go 485. And then in this Y statement, we're thumbing down. That means the numbers are getting bigger. So I want to choose a number bigger than 489. So let's choose 495. We're creating a dead spot where we want to assign 0 to that further down in the code. For this line, we are thumbing to the left. That means that the numbers are getting lower. So in this case, let's go with 505. And in this case here, thumbing to the right, the numbers are getting higher. So let's add a little bit to it. We'll go 515. I'm going to keep everything by factors of 5 right here. So now if the Y value is 485, and here we're just going to change the values to what we changed up top, which means we have to change the X value here to 505 and this one right here to 515. Did adding the dead spot solve our problem? All right, liking it. I don't see any funky flitter. All right, it seems to be, and see, I can go all the way around like this and light them all up. Let's check the button. Oh, something is funky there. What is going on? Oh, now we created a whole other problem. And now sometimes it doesn't turn all the way off. I figured I'd take you guys through the troubleshooting process so that way you still have some hair on your head when you are done. So one of the things that we have not done in this code is that we have a range from 485 to 495. In the middle of that, it's not defined in the code what we want to happen. We're just assuming in our head, like, yeah, the LED goes 0 because once it hits 485 here, well, that's going to correspond to 0. But the Arduino, it's kind of like one of those wish genies where you make a wish, but the genie always finds a way to like totally screw up your wish. And that's Arduino. It knows what you're trying to do, so just like do it. But no, you gotta like be so specific with your wish so you don't screw up your life. So we've specified what we want in all the directions, but we have not specifically told the Arduino if it's within this 10 by 10 kind of block, you need to turn everything off. So the Y value, if it is greater than 485, and if the Y value is also less than 495, basically what we're saying, if the Y value is in between 486 and 494, we want the LEDs to be off, but also the X value. So let's specify that. And the X value, if it is higher than 505, and if it's also less than 515. So with this statement, we're basically hardcore defining that dead spot. And so we're going to analog write everything. So the up LED is going to be 0. We're giving it a brightness of 0. I think we are ready to make a wish on our genie. Throw major shade, intimidate the code. I'm going to start with the red. Yes, the green, the yellow, and the blue. And we can go around in circles and then clockwise circles, but now the button. There we go. Everything works as it should. It is now reliable because we created just a little bit of a dead zone. See, I can kind of just barely move it around and nothing happens until you really start to get going. Guys, we figured it out and I still have a whole bunch of hair. If you guys have any questions about the circuit or the code, I encourage you to post below. But even better, I invite you to join my community where every week we have live video chat events. There's live workshops to deep dive into individual components. But best of all, it's a place to kind of be your sounding board when you feel really stuck. Every month, there is a new Arduino project challenge, which we build and code along together. Link for the community is below. Guys, I had a blast, and next time we are going to be controlling servos with the joystick. So I hope to see you there.